Welcome to the audiobook, where we dive deeper into the fundamental building blocks of Kubernetes. In this chapter, we'll explore key Kubernetes concepts like nodes, pods, services, deployments, and RBAC, and understand how they all fit together to form a robust container orchestration platform. Let's begin with the node. The building blocks of the cluster. A node is the smallest unit in Kubernetes. It can be a physical machine or a virtual machine, running containerized applications. Each Kubernetes cluster is made up of at least one or more nodes. These nodes are responsible for running the pods and are managed by the control plane. A node consists of three main components. Kubelet, an agent that communicates with the control plane and ensures containers are running as expected. Kubeproxy, handles networking and load balancing within the cluster. Container runtime, software like Docker or Containerd, which is responsible for running the actual containers inside pods. In short, nodes are the workers of your Kubernetes cluster, doing the heavy lifting by running the containers that host your applications. Pods, the smallest deployable unit. Now, let's zoom in further to the heart of Kubernetes, the pod. A pod is the smallest deployable unit in Kubernetes. It represents a single instance of a running process in your cluster. Unlike traditional virtual machines, a pod can run one or more containers, usually tightly coupled to work together. These containers share the same network namespace, meaning they can communicate with each other using localhost, and they also share the same storage volumes. While a node is the machine, think of a pod as the package that contains one or more containers. Each pod provides the environment your containerized application needs to run, including storage, network access, and configuration. Pods are ephemeral by nature, meaning they can be created and destroyed based on the needs of the cluster or application. Kubernetes makes sure that pods are running as intended and will restart or replace them if they fail. Services, stable networking for pods. Now that we have nodes and pods, we need a way for these pods to communicate with each other and with the outside world. This is where services come into play. A service in Kubernetes is an abstraction that defines a logical set of pods and a policy to access them. It provides stable IP addresses and DNS names, enabling communication between pods in a way that is independent of the dynamic nature of pod creation and deletion. There are several types of services. Cluster IP exposes the service only within the cluster. Node A port makes the service accessible from outside the cluster on a specific port. AA load balancer provides a way to expose the service externally through a cloud provider's load balancer. By using services, you can ensure that even as Kubernetes creates and destroys pods dynamically, your application can consistently connect to the resources it needs. Deployments, managing the lifecycle of pods. Next, we need a way to manage and scale pods efficiently. Enter the deployment. A deployment in Kubernetes is a higher-level abstraction that allows you to define how your pod should be deployed, scaled, and updated. Instead of manually managing each pod, a deployment automates the entire lifecycle. With a deployment, you can roll out new versions of your application without downtime, using rolling updates, scale your application up or down to handle increased traffic or optimize resource usage. Deployments ensure that your application is always running the correct number of pods in the desired state, making it a critical tool for running production workloads in Kubernetes. RBAC, securing your cluster. As your cluster grows, security becomes increasingly important. Kubernetes provides a flexible security model with role-based access control, or RBAC. RBAC helps control who can access and manipulate resources in your cluster. It works by defining roles and role bindings. Roles define a set of permissions, specifying what actions can be performed on which resources. For example, a role might grant permissions to create, delete, or view pods. D-role bindings link roles to users, groups, or service accounts, effectively assigning those permissions to specific identities. There are two types of roles in Kubernetes. Namespace-bound roles. These are scoped to a specific namespace, meaning they only grant permissions for resources within that namespace. Cluster roles. These are cluster-wide and grant permissions for resources across the entire cluster. RBAC enables fine-grained control over who can do what in your Kubernetes cluster, which is vital for maintaining security and preventing unauthorized access. Conclusion. Putting it all together, Kubernetes is a powerful orchestration tool because of how it seamlessly integrates these core components: nodes, pods, services, deployments, and RBAC. Nodes serve as the foundation, running pods that host your application. Pods are deployed and managed through deployments, while services ensure reliable communication. Finally, RBAC controls access and secures your cluster. Each of these components plays a vital role in the day-to-day operation of a Kubernetes cluster. Together, they provide a flexible, resilient, and scalable platform for running modern containerized applications.